So we're continuing our exploration of various forms of quadratic equations, and this form is currently in this equation is currently in standard form, and we want to convert it to vertex form. And the question often comes up, why would you do that? Well, I want you to look at this graph right here. This shows the height of something that I threw in the air after a certain number of seconds. So at 0 seconds, it was 12 feet in the air. Okay, so apparently I was standing on a platform or something when I threw it. And then it went higher and higher and higher, and then as things do, it eventually stopped and then fell back down. And you can see on this graph that it took, I don't know, a little over 3 seconds to hit the ground again. And what I'm interested in is how long did it take to reach its maximum height, and what is that maximum height? Well, you can see on the graph, if this is 1 and this is 2, then this is 1.5. So at 1.5 seconds, it reached its maximum height, and that maximum height was 48 feet. So you can tell that from the graph, but you can't tell that from the equation. But if I can write the equation in vertex form, which looks like this, and we'll learn to do this soon, y equals negative 16 t minus 1.5 squared plus 48, you can see from your experience that this is going to reach its maximum at 1.5. You might remember the whole thing about this being the horizontal shift of 1.5, and indeed the parabola shifted over 1.5, and then it shifted up 48. So you can read how long it took to reach its maximum right here, and what that maximum is right here, right off the equation. You don't need to try to graph the thing to see. So we'll be learning about how this works here. By the way, in case you're wondering where this equation came from, if you imagine covering this up for just a minute, let me just cover this part right there, pretend it's not there, and also pretend this isn't there. If I put in 1 for t, then I'd get 48. And if I put 2 in for t, I'd get 96. And if I put 3 in, I'd get whatever 3 times 48 is. So what this is doing here is, if you threw the thing up in the air at 48 feet per second, then 48t would be how high it is after t seconds. Well, now I want you to go back and add the 12 on there. Apparently, I was standing on a platform that was 12 feet high, which is what we saw here, because if you put in 1 second here, it's not 48 feet, it's 48 plus 12. And if you put in 2, it's not 96, it's 96 plus 12. So this gives you the height. Well then, what about this part right over here? Well, Sir Isaac Newton reminds us that gravity pulls the thing back down. Okay? And that's how much it pulls down every second, is negative 16t squared. And there's some physics in there. You could learn that elsewhere or talk to me, but that's where that equation came from. I didn't want you to think it was just magic. So we're going to be learning about how to convert these things from standard form to vertex form. And to start into that, I want to step over here to a Desmos graph that we have worked with, and I want to ask you the question. This is from previous work. Oops. Where is this one going to be shifted? Okay. So let me just turn this one off for a bit and this one off there, and just ask you this one. How far is it shifted in which direction? And if you remember from previous work, we found that if you took this number and cut it in half and made it the opposite, that told you the horizontal shift. Let me move this thing back over here. And sure enough, if you let me put this back at a reasonable, if you're looking at this thing here, shifting to the left and down 6, you can see that left shift right in here of 4. It was half of this number and then the opposite. So with this one, we'd expect it to shift to the right 5, okay, because it was half of this and then the opposite. This one, let's see if that works. Yep, there it is, right 5. Okay, and what about this one? What direction do you think it's going to shift? Well, half of this is 6, and then the opposite would be negative 6. So we're thinking it should shift 6 to the left. Let's see that. Okay, cool. So now what I'm going to do is mess up this thing just a little bit. Okay, I'm going to put right in here a 2, and I want you to see what happens to the graph. Okay, now how far is it shifted? Well, it was shifted left 4, now it's only shifted left 2. Okay, what if I put in a 4? Well, now instead of being shifted left 4, it's actually shifted just left 1. Well, that's strange. How about this one here? Let me turn that one off. Right in here, it was shifted 5 to the right, but I'm going to put a 2 right there. Okay, and where did it go? Great, lost it. There it is. Okay, it looks like it was shifted. What, 2.5? Huh. Well, what's happening is this. Instead of just dividing this by 2 and then making the opposite, we also divide it by this number. Let me go back and look at that one again. When it was just a 1 or blank, it was shifted to the left 4. When I put a 2 in there, now it's only shifted to the left 2, half of that. Okay, so what you do is you take the number here, divide it by 2 and make it the opposite, but also divide by this one. So let's check out this one right here. We know right now it's shifted to the left 6 because it's half of this and then the opposite. But if I put a 2 in here, okay, instead of just -6 to the left, it's going to be -6 divided by 2. So we'll have to go find it here. There it is. A little bit difficult to tell, but it is indeed shifted just -3. So what you're doing here then is looking at graphs and saying, all right, take this, cut it in half, make it the opposite, and then divide by that, and that tells you the horizontal shift. So let's see what this one is. 12 divided by 2 is 6, make it -6, and then -6 divided by 3 is 2. I'm sorry, -2. And there it is, shifted -2. On this one, it doesn't matter whether you take the opposite first or cut it in half first or even divide by that first. You just got to do all three things. So let's make this negative or positive 10 divided by 5 is 2, so it ought to be shifted to the right 2. There it is. Okay. This one, a little bit difficult to see. What are those numbers out here? Okay. If I take this number, cut it in half, you get 12. Make it -12, and then divide by -4, I get +3. So I'm expecting a shift to the right of 3. Okay. And there it is. So what we did back on this graph right here was take 48, divide it in half, you get 24, make it -24, and then -24 divided by -16 is indeed 1.5. Okay? And then the question comes up, how'd you get the 48? Well, just like what we did before with changing things to vertex form when there wasn't a number out here, we said, look, I know the x-coordinate of the vertex. What's the y-coordinate? Well, what we'll do is just put 1.5 right in here for t and calculate that. Okay, so let's get a calculator here. And in case you hadn't realized it, if you go to Desmos and type in, instead of desmos.com/calculator, if you just type in scientific, you get a calculator without a graph on it. So let's just type this in, -16 and then 1.5 squared. Remember, we're putting in 1.5 for t, plus 48 times 1.5, and then plus 12. Oops. So I'm simply putting in 1.5 for t right there, and then calculating, and sure enough, there's my 48. So now I know that the y-coordinate is 48. So we can say, look, we knew it was shifted to the right 1.5, so that's why we put in minus 1.5 inside the parentheses and then squared it. We knew that it was going to shift up 48 right there. Okay, so we put a plus 48 out here, and then it turns out that whatever coefficient, whatever number is out front of the t squared, you just put that right here. So let's look back at some of these. With this one, first I found out that the horizontal shift was take 12, make it, cut it in half, you get 6, make it -6, and then -6 divided by 3 is -2. So we found the horizontal shift of left 2, -2. And then how do you find out what this is without graphing it? We can tell it's 1 right here, but how do you find that out? Well, what we'll do is put in our -2 for x right there and x right there, and then see what we get. So let's go back to our calculator and clear this, and we'll make this 3 times -2 squared plus 12 times -2 plus 13. Oh, I have an accidental negative right here. There we go. And we get 1. So again, I was putting in the -2 that I found from cutting this in half, making it negative, and dividing by this. I put that number back in here for x, and that got me 1. So I could have written this equation right here in vertex form without having to graph it. So let's do another one here. Get rid of this, and we know that this is at 2, -2, but how could I figure that out without graphing it? Well, first take this number, cut it in half, you get -10, make it +10, and then divide by this, so you get 2. So we had a +10 divided by 5 is 2. So now we know that the, let me just shift this up a little bit here, and can I do this? Yeah. I'm working with this equation right here. 5x squared minus 20x plus 18. Okay. And I found out already that it's shifted to the right 2. So now I'll put 2 in for x right here. And calculate. Okay, so we'll get a calculator here. You're welcome to do this by hand or in some other calculator, but I like to be able to show this here. So 5 times 2 squared minus 20x, so minus 20 times 2, and then plus 18, and we get -2. So let's put a -2 in here. And so now we know that inside the parentheses we've got to have x minus 2 because it shifted to the right 2. Okay? And then it's got to shift down 2 as well because it goes down to the y coordinate of the vertex is -2. So it goes down 2. And then whatever number is out front here, we'll just put that right there. And now we've converted this to vertex form. So you're going to do some practice with putting these into vertex form. I'll have you practice a few just to see if so you know whether you're getting them right or wrong, and then I'll ask you to write a few of them yourself. All right, that should do it.